getting a cookie. Yeah, don't worry about that. Okay, yeah, I don't know. Okay, so, y'all, on the front of your notes, this is the homework. Make sure you have your note page. Bless you. So yesterday, we talked about symmetry, right? We talked about x-axis symmetry, y-axis symmetry, and origin. Okay, does everybody remember this? Okay, so today what we're going to talk about is odd and even. So a function is even if it's symmetric around the y-axis. And so the easiest suggestion for this one is y equals x squared, and that graphs a parabola, right? And that folds around the y-axis. So that's our even function in the most general form. An odd function is a function that is symmetric to the origin. And the best one of this to the simple one is y equals x to the third. Because that one, if we rotate it 180 degrees, it's the same graph, so it's symmetric around the origin. And the good news for this one is the algebraic check is the same every single time. We always use a negative x to check. And so if I put a negative x in my x squared, then I get the exact same thing back. So the final and the original will be the same. On a cubic or an odd, I end up with a negative of the function. So you have two options here, friends. The even, if I put a negative x in, all of the signs stay the same. And the odd, all the signs change. They're all the opposite. So O for odd, O for opposite. Okay? O for odd, O for opposite. So this is how this is going to work. I'm going to substitute in a negative x. And when I substitute in a negative x, I get negative x to the third power. So I'm doing negative x times negative x times negative x. And what is that? Negative x to the third. And then minus and minus becomes. So every single one has to change. So the first one's positive, and now it's negative. This is negative, and now it's positive. All the signs changed. They're all the opposite, so this is odd. And it says, what's the symmetry? So it's symmetric with origin. Odd and symmetric with the origin.
So how do we know that it's odd? What about that? Odd?
Are the signs the same?
Okay, so how do we know that
All the signs are going to change. That makes it odd. The algebraic check, you put a negative x in. Okay? Both times. Both times. The same every time. You always put the negative x in. If all the signs change, it's odd. If all the signs are the same, it's even. Okay? So here, I'm putting the negative x in. Joseph. What's a negative x squared? Are you sure? You are correct. Because a negative times a negative makes it positive, and it's x squared. So I'm going to put x squared, but I have to keep the negative, and then plus 6. So we put the negative x in, right? Just like we did over here. This time, did the signs change from the original? No. They're all the same. In the original it's negative, here it's negative. In the original it's positive, here it's positive. They're all the same. If they're all the same, that's even, and that's symmetric with the y. So number 9. So what did we decide negative x to the third power was? Okay, so we said this then is negative x to the third. Negative x squared becomes positive x squared. And then a negative times a negative is a positive. So now look. The first one was positive, and now it's, the second one was negative, and now it's, and the third one's negative, and now it's, so did all of them stay the same? Did all of them change? If the answer is no, you only have one other choice, and that's neither. So it's either they all stay the same or they all change. If neither one of those is true, it's neither. So number 10. Bless you. When I put the negative x in for x squared, is that the same or different? Same. So this is even and symmetric with y. So on number 11, how do I start this one? Right, every time. So I'm going to take f of negative x. So it's a negative divided by negative. So I get 8 over x. Is that the same? Did it change? So if it changed, what is it? Odd. Now, okay, so what changes? So is it the 8? Because when I look at this, this is what I'm going to write. It's like negative 1 times that, correct? So this is like positive 1 times that. So did the sign change? It did. Because it's not negative anymore, now it's positive. It doesn't matter whether the negative's on top or bottom, it doesn't matter. Okay, so before I start the last one, I want to ask you this question. If I want the absolute value of negative 5, what do I get? 5. If I want the absolute value of negative 5 plus 1, what do I get? I get 4. So when you did that, Ruben, did you take negative 5 plus 1, or did you do positive 5 plus 1. You did negative 5 plus 1. Inside there, you couldn't change that negative 5 to positive 5, right? But we changed this negative 5 to a positive 5. Why can't we do it here? Because of the plus sign, right? So if I make this a negative x, can we change the negative x to positive? No, because of the plus sign. Okay? So when I put in a negative x, and I look at the signs, this is positive, now it's negative. This is positive, this is positive. Did they all change? Did they all stay the same? So what's the only option? Okay, so on the back of your homework, I want to work one with you. So look at number 10. If I substitute in my negative x into the function, is this the same or different? Okay, so this is like positive 1 times x over 7, and this is like negative 1 times x over 7. So did it change the sign? It did. So this one is odd. And the last one I want to help with is number 12. So if I put a negative x, so when I write this now, is there a plus with this one? There isn't. So if I have this, 5 times negative 6, what do you get? 30. So you took the 5 times 6 and you made it positive, right? So for this one, I'm going to take 5 times x and make it positive, which is going to be, so did any of the signs change? So this is even. And it's symmetric with the y-axis.